I'm excited about our panel today. My name is Brad Merriweather. I'm the CMO at View. We've got a really good panel talking about LED technology, kind of the current state of affairs, future trends, where the industry's headed, all that good stuff. So I'm going to start by having our wonderful panelists introduce themselves. Jason, why don't we start with you?
Perfect. I'm Jason Barrick, Vice President of Unilumin USA. I'm filling in for Nick Fazio this afternoon, and looking forward to talking about nits and bits.
My name is Paul Johnston. I'm with Unilumin, of course. I'm the Technical Operations Vice President, and good to be here.
And my name is Nedi Nader Shahi. I'm a Chief Scientist with Unilumin. Also glad to be here.
So let's do this. I'm actually going to start off script for you guys, but I want the audience to understand your backgrounds a little bit. So why don't you explain just briefly kind of what you've done in the LED technology space in your background. Nedi, we'll start with you.
Okay, so first of all, I'm relatively new to LED display industry. I attached myself to this industry in 2009. Prior to this, I was always in the semiconductor industry, and I had my own company doing RF-related microelectronics. So in 2009, I joined the LED industry and proceeded to build 3 generation of LED drivers for the company that I was working with, and I was the CTO of this company. And soon after that, I joined Layered as a chief scientist and built another LED driver for them. And so now I am with Unilumin as a chief scientist and working on future display technologies, some of which obviously is sort of difficult to talk about openly.
Every LED company needs a mad scientist, and that's Nedi.
Right. With the emphasis on mad, yes.
Does he have his own basement, his own lair where all the magic happens, you know? Paul, why don't you go next?
I started actually in 35 millimeter and 70 millimeter film, doing motion picture for a long time, worked for a lot of the studios. And then as I migrated in, I ended up installing one of the very first DLP projectors for digital cinema and helped with the DCI initiative for a very long time, working with companies like Christie Digital and Barco. And that's what got me into the space primarily. And then as I worked with Barco, they were one of the leaders at the time for direct view LED. And there was a time that I think they had about 85% market share early on. And so that's when my LED career kind of started, and that was about 20 years ago. So since then, we've just been pushing the technology, from indoor to outdoor to virtual production, doing motion picture, you name it, including also retail and sports as well.
So I'm not a youngster in the LED space. I've been in LED since 1996. Back then, we were doing truck stops and movie theaters and price changers. But I've been fortunate enough to really see the evolution of LED. Starting in 2000, I moved to New York City and worked in the development of a lot of the big Jumbotron spectaculars that you've seen in Times Square. And with the advent of fine pitch LED in the around 2010 or so, I saw the evolution into the broadcast market. A lot of the first set pieces that you'd see on Good Morning America, ESPN. And then as that product's advanced, prices came down going into the retail market, experiential, and here we are today. So awesome. Very excited to be part of Unilumin and what we're doing here in production.
Thank you, guys. All right, so first questions for Nedi. Let's talk active matrix. Is this on the horizon for LED displays, and how is it going to change the market?
Very much so, yes. It's sort of a natural transition from where we are, which is passive matrix. And as some of you know, specifically about the LED industry, passive matrix is predominantly used in our current products, almost exclusively. But it has a lot of legacy issues, artifacts, visible artifacts, and issues that are related to the matrix of the network that the LED drivers have to drive. Active matrix is basically replacing this technology by essentially dedicating a driver to a particular pixel. And amongst other things, it actually provides a facility to do a lot more signal processing, not just driving the signal. And that is a huge advantage. So immediately what we would see as an advantage for the active matrix is a higher brightness, as well as the fact that we can in excess of maybe 480 hertz, as opposed to 60 hertz right now, which is fairly common in our industry. So not only refresh rate, but also the brightness. And of course, you combine that with the fact that all these visual artifacts and unfortunate issues relating to the screen that disappear as a result of it. So very much our future, yes.
So, Jason, with the technology changing and advancing so rapidly, how does someone investing in an LED volume future-proof for LED?
No, that's a great question, Brad. As everybody knows, when you are investing in LED, the majority of the cost is the screen. And so looking out, I always tell people to plan for not only what they're going to do day one, but look to day 361 and beyond. That'll really help you gauge on what you may need. Also looking at pixel pitch, and also looking at also the other peripherals, the other items that are part of your solution. You want things that are going to be scalable, both backward and forward compatible potentially. You want to also look at your client base and look at where the technology is going. But to me, the key is really look at what you think you may want 2 years from now. And also you want to work with a good group of folks. You want to make sure that you've got good support for your product for years to come. You want to make sure that they've got service and support here in the US.
Yeah, I mean, the support element is a real key thing, because what happens is you're dealing with a very heavy investment cost, right? And if you're only looking at tomorrow and you're not maintaining that system, that investment can decay very rapidly if it's not properly maintained. And the overall performance and stuff could also be put at stake, which could compromise your own name and brand of your own business and what you're trying to achieve. It's a small world. Everybody knows everybody, so you better make sure that you maintain that positive image.
So, Paul, I'm going to stay with you for the next question. How are advancements in bandwidth and processing speed going to help productions going forward?
Well, as we continue to drive into higher frame rates, right, we also diving into tighter pixel pitches, like we have a 0.4 over here, right? We're getting pretty tight there. We're also dealing with higher brightness, and as we're pushing a lot of data, right? And we're also dealing with both not only 8-bit spaces, but now we're working in 10 and 12-bit as well. All of those consume lots of resources, right? That also means more cables, more data cables, more processing, and more complexity. And so by having higher bandwidth, that's really going to allow us to kind of simplify the system. And instead of saying having 16 trunks, you're only going to have 4 trunks, for instance, to be able to get that same level of performance. So we got to make sure we're chasing that at the same time. Otherwise, we're going to start adding too many points of failure, and then it becomes unstable. And obviously, it's also very costly from a labor standpoint of both installation, service, and maintenance.
So when you're planning for the infrastructure of an LED volume, are there things to consider, rules of the road? How do you approach the infrastructure involved?
Well, I think the biggest thing is out of the gate, we need to understand what the application is and how you're using the system, right? So that way it can be optimized. We're going to make sure that we're selecting the right products. We want to make sure, and that's everything from not only the correct tile and pixel pitch, but also the type of processing. We do have multiple options in processing, and they all have their own benefits and feature sets as well as different price points. So we want to make sure that we're looking at all that up front. And then on top of that, we want to couple that with who is going to be your support plan, who are you using for services, right? How is the system being used? Is it a 24/7 operation type environment? And making sure that all of those elements are taken into account from day one in the planning to the execution and installation.
So we've seen some companies experiment with RGBW panels. How do you feel this will help advance the market? Is this cost prohibitive? Talk a little bit about RGBW panels.
We're already doing testing, right, and experimentation, and there's some product here. Also showing it off with Brompton over at Brompton as well, who we also use. So it's very exciting to see, but obviously any new emerging technology is going to be very, very expensive initially, and there's a lot to do, right? There's supply chain elements, right? We got to also see how many suppliers are going to be out there and going to be able to create a competitive component that we can integrate into that. And obviously we have a lot of testing. It's new, right? So we need to see what is that going to take. It's also going to it's going to address that bandwidth issue that we talked about earlier, right? It's another whole pixel that we're driving. It's going to have more heat. It's going to have more current requirements. So we have a lot of things that we got to really work through to really bring it to market. And then most importantly, we got to see how will the market receive it, and also will we be able to hit those cost targets to where it's going to move forward and multiply, or will it be something that becomes too costly and then we'll have to look another direction potentially in order to achieve the type of performance we're expecting out of an RGBW product?
Daddy, anything you would add?
To be honest, at this point, I think just like what Paul was saying, it's under study, and amongst other things, what we need to decide is whether or not it's economical for us to actually address the brightness issue with the addition of a pixel in a package, or by just working with our suppliers to make sure we have higher efficiency in the R and G and B, therefore achieving higher brightness with the same current architecture. So those are the things that we are evaluating right now.
Natty, I'm going to stay with you for my next question. So our talk is bits and nits, and we can't talk bits without color. So I want to go into color next. What color spaces are currently available in the market? Can you explain the science of how different diodes support specific color spaces? And when do you think we'll see support for BT 2020?
So the last one, the most difficult one first. I think the 2020 spec is the hardest to meet, but we are going to achieve it. In fact, we would be able to maybe demo it soon. I need to explain that in order to achieve these things, what it takes is selection of LED wavelengths that are at the fairly close to the edge of the CIE color space. And these are not easy to do. So you have to work with the LED suppliers to be able to actually get the specific wavelength. And it's not just the wavelength, because you need to be able to narrow because the wavelength that you actually get in terms of a specification is usually a bell curve. So you need to be able to get a very narrow bell curve, and then the peak should be close to the very edges of the CIE space. And this isn't a very easy thing to do, because LEDs are made out of junctions, and these junctions, the way they are manufactured, they essentially you get the end result is some wavelength that the material that you use produces. There are ways to actually improve efficiency easily by tricks of the manufacturing, but changing the wavelength is not so easy. So you almost have to investigate the material that you're using in order to be able to achieve that. So we are working with our suppliers to actually achieve those kinds of wavelengths and in narrow band. And there may be some that are in existence, but I can't tell you that it's in large volume availability at this point. So they are achievable, but not immediately. As far as the rest of these standards are concerned, they're all easy to do, and they're all available from our products, including the next difficult thing, which is a DCI-P3. So all of those are available.
Okay. So let's shift into processing next. I know Unilumin supports Megapixel, Brompton, and Novastar. Paul, talk about the differences between these and why it should matter.
Yeah, I mean, obviously there is a price differentiation between them, and their portfolios are very different. Like for instance, Novastar has an incredibly large portfolio, mainly because they're found in just about every application, right? So they've got small boxes with 4 ports and 2 ports, and they've got some with integrated players, and they have some units that are just giant switches where you can drive, 20 outputs or beyond now, right? So there's a lot of flexibility in their portfolio, and I would say they have the largest out there for sure because they feed a lot of markets. When you get into Brompton or Megapixel, they have a little narrower focus on the markets in which they serve. Not that they couldn't be used in other spaces, but some of those spaces they're a little cost prohibitive because they have a lot of features that aren't necessary, right? At the end of the day, the UIs are different between all the systems, right? They all have advantages and I would say disadvantages between each other on some of those feature sets. But really our job is why we supply all of them is that because we work in so many spaces and also every application is not the same, right? So we want to make sure that we're able to optimize based on your budget, based on how you're going to use the system. And by offering all 3 different types of processing solutions really allows us to optimize and customize and tailor it to that application and the need of the client.
Paul, I'm going to stay with you for my next question. So do you anticipate standardization in the market? Amongst the manufacturers of LED panels, what does the landscape look like when it comes to product and spec standardization?
We are participating in certain things, like for instance with ETC and USC, we've sent some stuff down there, and there's been some other standardization things that are done either internally with ourselves or with other outside groups. But it is a big challenge. It's a big challenge because you really have to get all the big key manufacturers to want to play the same game and agree on something. And it's kind of tough because a lot of us, not necessarily us, but getting other manufacturers to kind of open kimono a little bit on some of these details is somewhat the secret sauce that we all hold as well. So will it happen? I definitely see that there'll be some standards that could potentially come, especially in virtual production and in the cinema space, where telemetry is a really key thing. But for a lot of the other markets, it's not really necessary. And in most cases, people are looking at the brand itself as kind of the standard for it to meet their needs of reliability, performance, infrastructure, services and support, and those key things, which tend to be really critical for a lot of the other spaces. But it's definitely a challenge. We're definitely willing to participate in doing so in certain cases, but I can't tell you when an actual standard would come about.
And I've got 2 more questions, and then we'll open it up to the audience. So be thinking about questions that you have for our panelists. My next question, Nettie, is for you. Talk a little bit. I know there's plenty of top secret stuff that is going on in the R&D space that you can't talk about. But talk about the latest developments in LED technology, how it's kind of shaping the market, and specifically what it's going to do for production environments.
So the things that we do or we can talk about are maybe advances in how we actually plan to package our future LEDs and therefore build our future displays. As you know, we've had the SMDs that transitioned into IMDs, and then we went to COBs and so forth, and even flip chip COBs. So what we do have now is a lot of different variations of what we call a micro-in package. So we have officially entered into the realms of micro devices, and you see a lot of products relating to micro devices. Most of them are not really micro. So, but what that does for us is that obviously the micro LEDs are smaller, and they need to be packaged so that we can take advantage of SMD machines to be able to place them on the devices. The alternative to that is the chip on board, which has its own issues. So one of the latest things that is relevant to us is the so-called wafer level chip scale packaging, which essentially means that you take the dies and you place them on a substrate that may itself be a piece of CMOS, so a semiconductor CMOS, and then through the concept of TSV, which is through silicon vias, you actually create the connectors at the base of this CMOS substrate. So you have connected bumps at the bottom, and this creates a sort of a packageless SMD package, if you like. So essentially all you have is the die itself and the components, maybe one die or one set of die RGB, or maybe multiple RGBs are on the top side, and on the bottom you actually have the connectors. And there is no plastic molding, there is no cavity, there is nothing else. So therefore these were very, very small. But because you use micro LED dies, the so-called black to light ratio is very high. That means the package itself, or the silicon piece of silicon where these dies sit on, is mostly black. It's actually painted black, literally. So the only thing that you see is the small dies, and the ratio is in the order of 90%. So your contrast is very high. But because also you use micro LED and efficiency of the micro LED fabrication is very high, your brightness is also very high. And finally, going forward, the latest thing would be that that same piece of silicon material that is now the substrate for these things can also be the driver. So you could actually physically build the driver inside those piece of silicon. And now you would have a chip that is, you could call it an intelligent chip. We call it UPC, or Universal Pixel Chip. So that device could be a sort of a solution to future product. A lot of people call that chip on CMOS, by the way.
So if you didn't believe Nettie was a chief scientist before that answer, surely you believe it now. Am I right? That was awesome. All right, so my last question, then we'll turn it over to the audience for questions. Jason, I want to come to you with this. So when it comes to LED technology, I mean, you're really dealing with a lot of the same component parts from one display to another. So how does one display differentiate itself from another?
Sure, that's a good question, Brad. So when you do look at the industry as a general, one could argue that it's commoditized. We are all getting the same diodes, same drivers from a lot of the same component manufacturers. So what's our secret sauce? What makes our product better? A lot of it comes down to a couple different things. One, you look at the mechanical design. You look at the wall behind us, it is flat as a board. And the way that these cabinets come together is so precise, especially when you get into the tighter pixel pitches, the tolerances have to be exact. And so that's one key thing right there. Also, when you look at, as Paul referenced before, the different processing platforms, the vast array of options that you have with Unilumin, you're not going to find with other manufacturers. The other thing goes into a lot of our processes when you look at how we are manufacturing our displays. Our QC process, also our service and support here in the US. So there's really a myriad of things that you really look at. I mean, sometimes I liken it to, you can have two kitchens with the same ingredients, and one dish you're going to throw in the garbage, the other you're going to order a second. So it really comes down to processes, people like Nettie, people like Paul that are really leading the charge, and also the fact that Unilumin really leads through innovation, through collaboration. So our partnership with the team at View here, our R&D departments working together, it's all that collaboration that really delivers the innovation that you see in some manufacturers over others. And I'm really proud at some of the things Unilumin is putting out today, and I'm really excited about some of the things that Nettie can't talk about.
That's awesome. All right, so let's open it up to questions. Any questions from our audience? If so, hand raise and we'll find you with a microphone. Don't be shy. Are you guys going to make me throw a question out? Is that what's going to happen here? Let's talk scan rate, Paul. What is it, and how low do you need to go for production purposes?
Currently, right now, obviously there's a myriad of different scan rates based on each product, pixel pitch, size, and also the environment in which it's intended, right? So, it's not uncommon to have a 30 to 1 or a 16 to 1, and you can get all the way down to 8 to 1 or beyond as well. For us, it's the number of pixels that are driven off a given IC, right? So as you get into a lower number, it means you're not maxing out the performance of that. You're going to get far more efficiency and speed, and that's going to translate to an overall better experience. But it also does translate to higher costs because you need more ICs on that board, and you also need to make sure you have enough space for those ICs. So when you start getting into sub 2 mil, it can be very, very challenging getting as low of a scan rate as you're wanting to achieve because there's only so much space on that board to stack those ICs. As of right now, the industry is for virtual production and these environments for image capture, like motion picture, etc., has really been a 16 to 1 is kind of the sweet spot. However, with higher frame rates, higher shutter rates, people are capturing at much faster speeds, doing higher image capture. We're seeing it push down into the 1.8 now. So a lot of our products that we're bringing out now, we have in a 1.8 or a 1.12 that's also helping address those. Overall, what it's going to translate to is as you have those higher scan rates, you're going to get flat fields. You're not going to get banding. You're not going to get artifacts that are going to be are going to be seen not necessarily by the human eye, but you will see it on the camera. And so, as we continue to dive lower and lower, it's all part of the evolution of better performing products.